Okay, so this is designed to be the practice test for the Chapter P test. The idea would be if you could do every problem on this in this section, you should be able to do every problem on the test. When I write the tests, I generally have the review open and I kind of switch the order of the problems and switch the numbers in the problems, but the instructions will be the same. So there's likely going to be a problem like number 1 or number 2. The instructions will be simplify. There's going to be problems like, you know, number 9 through 12 where you see something with a 0 exponent and it asks you to simplify. So everything on the review is possible to be on the test. The instructions will be the same, but the letters and numbers may be different and the order of the question may be different. Probably the best thing you could do before watching the videos is you should try to complete the review by yourself and then watch the video. Because it's easier to watch me do something and think you understand the concept, and much harder to do the stuff without, you know, me doing it for you. So I think it's a much better study skill or preparation for the test to do the review and then watch the video, and instead of having to write everything down that I do, just kind of check your work as you go through the video, and hopefully maybe I make some comments that help you out. Also, you want to make sure that you turn in your homework by the deadline on my webpage. If you want to be able to use a note card, because if you take pictures of your homework and email it to me, scan your homework and email it to me, or bring it to my office, which would be all the odd problems from sections P1 through P6. You really don't have to give me the review section if you don't want to. And if you do that by the deadline, then when you take the test, you may use a 3-inch, which is by 5-inch, which is a smaller note card. Don't take a 5x7 note card. If I see you with a 5x7 note card, I might just snag it from you. So 3 inches by 5 inches. I don't know. That's, you know, kind of, that's probably smaller. I don't know. Maybe something like that. That's probably not 3x5, but they're not big. Maybe it's about like that. It's not the big one. So I'm going to start doing the problems now, and I'll try to show as much work as I think you need to see. And I might show more work than you show. On a lot of these problems, the first 2 problems that I see on the review here, I could write down an answer without showing any work because I could do all this in my head. That's fine to do, but it leaves me no room to give you partial credit. So if you make a mistake and you don't show any work, you're not going to get partial credit. But if you make a mistake and you show your work, then you'll get some sort of partial credit. So for problem 1, when we did these, I dropped the parentheses because a times sign means multiplication just as well as the parentheses did. And then back in section P1 when I did this, I reordered, grouping the numbers next to the numbers, the letters next to each of their corresponding letter. And then for the letters, I added the exponents. For the numbers, I multiplied them. And the x that didn't have an exponent was an implied exponent of 1. So my answer to problem 1, which I definitely could have gotten without doing any work, or at least showing any work, would be 6x cubed, y to the 6, all multiplied together. I'll do the same thing for number 2. I'm going to write it without the parentheses, putting a times sign where the 2 parentheses touched. And then I'm going to reorganize it, writing the -8 and the 2 next to each other. I need a times sign between, otherwise it'll look like -82. And then I'm going to write the s's, the s and the s to the 5th, and the t's. The letters that don't have exponents have implied 1s. Now I'm going to get my answer. I'm going to multiply the numbers together. Negative 8 times 2 is negative 16. S to the first times S to the fifth is S to the sixth. And t times t is t to the second when I add their exponents. So 6x cubed y to the sixth for 1. Negative 16 s to the sixth t squared for 2. That's perfect. 3 and 4 also could have been in section P1. They're division problems. And they're division problems where it's just simplifying the fraction. So in problem 3, I'm going to reduce the fraction 15 over 20. And I'm going to reduce the x to the fourth over x, and that x is really x to the first. And my calculator, which you're allowed to use on the test, or you can use a calculator on a test, will reduce 15 over 20 for me. 15 over 20 is going to reduce to 3/4. And I could have got that without my calculator going 15 divided by 5 is 3, 20 divided by 5 is 4. So 3/4 is going to be part of my answer. And then I have some options on how to treat the x. I can either put the x in the numerator of the fraction, or I can put the x after the fraction. The x's exponent is going to be 3 because I subtract the exponents on the x. And again, these are equal. 3x cubed over 4 is equal to 3/4 x cubed. That's probably the way I normally would write the answer, but this is equal, and if you wrote either, you'd be perfectly okay. As long as the x cubed wasn't in the denominator, you'd be fine. I'm going to treat 4 as kind of 3 problems. I'm going to reduce the 24 over 12. I'm going to reduce the x over x. And I'm going to reduce the y cubed over y. 24 over 12 reduces to 2. Again, I could break out my calculator and go fraction 24 over 12. My calculator will tell me that's 2, and it's not even a fraction, because dividing this by hand, 24 divided by 12 is 2. 12 divided by 12 is 1. So when I get the fraction 2 over 1, there's no need to write the over 1 because I don't need to write the denominator of a fraction when it's 1. The x's are going to cancel, and for the y's, I'm going to subtract the exponent of 1 from the denominator from the exponent of 3 in the numerator, and I'll get a y squared, and that's also not a fraction. So I don't need to write my answer as a fraction. And if I was going to write a fraction, the only thing that would be in a denominator is a 1, because this turns into a non-fraction when you subtract the exponents, that turns into a non-fraction, and the x's cancel. So 2y squared is the perfect answer for that problem. For 5, I have to cube the 3 and multiply the exponent of the 4. So I have 3 cubed x to the 4 times 3. 3 cubed, I don't need my calculator for, but you could use your calculator to find out that that's 27. And for the x, I had one letter with 2 exponents that I'm applied to it, so I multiplied those exponents, and I get 27x to the 12th for an answer. I'll treat 6 a lot like 5. I'm going to square the 5. I'm going to multiply the exponent on the x by 2. And I'm going to treat the y like it's the 5 because it doesn't have an exponent, and just square it. So this is how I deal with parentheses when there isn't an addition or subtraction. If there was an addition or subtraction, then you start doing things like foiling to reduce them. But when there's only straight multiplication inside of parentheses, then you can just apply the exponent to each of the individual numbers or letters. An answer for number 6, 5 squared, is going to be 25. When I multiply the exponents on the x, I get x to the 4th, and then I have the y squared. For both 7 and 8, I need to get the exponent away from the outsides of the parentheses. So in 7, I'm going to get this 3 incorporated inside the parentheses that it's attached to by making it 4 cubed, x cubed, y to the 3 times 3. And in the second parentheses, I'm going to get the 2 inside the parentheses that it's attached to by making it 2 squared, x to the 5 times 2, and y squared. Now I'll simplify those up a little bit. 4 cubed is 64, but I could have just did 4 exponent 3, and my calculator will tell me that that's 64. So the first parentheses, I get a 64. x cubed, y to the 9th, second parentheses, 2 squared is 4, x to the 10th power, y squared. Now I'm going to rewrite it without the parentheses and put the numbers next to the numbers, the letters next to the like letters. And I can do this because multiplication is commutative, and I can only do this scramble like this when there isn't any adding or subtracting inside either parentheses. 64 times 4 I think is 256. So 256 is going to be part of my answer. So I'm almost ready to write that answer now. So part of my answer is going to be the number 256. The exponent on the x is going to be 13. The exponent on the y is going to be 11. I'll treat 8 a lot like 7. I'm going to get the 2 inside the parentheses that it's next to by going 7 squared, x squared, y to the 3 times 2. And in the second parentheses, I'll get the 3 inside of it by going 2 cubed, x cubed. It would have been nice if I put an equal sign because it equals the problem above it. And then the first parenthesis simplifies to 49, x squared, y to the 6th. Second parenthesis simplifies to 8, x cubed. Now I'm going to drop the parentheses and put the numbers and letters next to each other. So 49 times 8, x squared times x cubed, and y to the 6th. The 49 times 8 part of this comes out to be 392. So part of my answer is 392. On the x's, I'm adding those exponents and getting x to the 5th. And for the y's, the exponent is 6. And just check over these real quickly to make sure I don't have anything that I hate. Feels good. I think those are both right. I'm trying to check my work to make sure I don't have any mistakes. 9 and 10 can be done without any work because I could use my calculator. We have to remember back in the section 2.2 when we had the 0 exponents, the only time something was a 1 was when the entire contents of the problem was in a parentheses and or if there wasn't a negative sign. 9 and 10, I'll do them both on my calculator. To do 9, negative 5 exponent 0, I get negative 1, because this is really negative 1 times 5 to the 0. The exponent of 0 only applies to the 5, and 5 to the 0 power is 1, and this whole thing reduces to negative 1. Whereas in number 10, the negative being in a parentheses, the whole negative 5 is the thing that's being raised to the 0 power, and the answer to this is going to be 1. So this was one of the 2 cases where you get 1 for an answer. The other case would be something like, like 7 to the 0. If you have a positive number to the 0 power, that's going to be 1. But a negative number without a parentheses to the 0 power is negative 1, but a negative number inside a parentheses to the 0 power was equal to positive 1. So that's going to be tricky on the test because not every time that you see a 0 exponent do you automatically get 1. There's only really 2 cases. 10 was one of the 2 cases where you get a 1. And I don't know if the other of the 2 cases comes up here. When I look at 11 and 12, one of them is equal to 1, the other isn't equal to 1. In 11, the exponent only applies to the x. I really have to think of this as 5 times x to the 0 power. There's a big separation. The 0 power only applies to the x, and the x to the 0 power, it equals 1, but the 5 isn't being raised to the 0 power because it's not in a parentheses. The answer to number 11 is going to be 5. Number 12 is just like number 10. If the entire quantity is in a parentheses with a 0 exponent, that always reduces to 1. It doesn't matter how ugly the inside of a parentheses is. If you have a parentheses with a 0 exponent, that's always 1. And then otherwise, if you have something to a 0 exponent, it's only 1 if it's just a single letter or a single number, like x to the 0 or 9 to the 0. These are the only instances where you get 1. Anything else with a 0 exponent isn't going to be equal to 1. So the 10 and 12, parentheses with nothing outside of it to a 0 power is 1. Then we didn't even have these examples, but a letter to a 0 power without a negative sign or a coefficient, and a number without a negative sign to the 0 power with no parentheses. Those are equal to 1. (13 through 17) I'm going to write with positive exponents, and generally that involves creating a fraction. That's the case in 13. In 13, I'm going to create a fraction, and I'm going to move the terms with the negative exponent to the denominator of the fraction, and anything that doesn't have a negative exponent is going to stay in the numerator of the fraction. So 13, the x doesn't have a negative exponent, it's going to stay in the numerator of the fraction. Both the 2 and the y had negative exponents. They're going to work their way down to the denominator of the fraction. That would be an acceptable answer, but we usually don't write numbers with exponents, so I should figure out what 2 to the 4th is, either by knowing it in my head and just writing it down, or figuring it out on my calculator, that 2 to the 4th power is 16. In 14, I need to make my negative exponents positive, and when there isn't any adding or subtracting, you can make a negative exponent positive by just shuffling it from one side of a fraction to another. So I've rewritten 14 with a big gap in the denominator, but in such a way that I can see what needs to be combined, and I've gotten rid of the negative exponents. First thing I'm going to do is reduce the fraction 24 over 36. I'll go 24 divided by 12 is 2. 36 divided by 12 is 3. So part of my answer is going to have the fraction 2/3. And again, if I'm not good at reducing fractions, I just go fraction 24 over 36, and my calculator tells me that that thing's equal to 2/3. The x's are both in the numerator, they're being multiplied, so I add their exponent. The first x has an exponent of 1, and I'll pick up an x to the 5th. For the y's, they're on opposite sides of the fraction, so I subtract their exponents. The y in the denominator had an exponent of 1. When you subtract the exponent, you leave the letter where the bigger exponent is. In that case, the y is going to wind up in the numerator. That's the answer I would write. It would be okay and equally correct if you wrote 2/3 x to the 5th, y to the 2nd for an answer. It's completely the equal answer. So this is all from P2, so hopefully you haven't forgot it completely. 15 and 16 have negative exponents inside. Well, 15 has a negative exponent inside of parentheses, and it has a negative exponent outside of parentheses. At some point, I need to get both the negative exponents positive. Usually I work the inside of the parentheses first, and so I'm going to get this negative exponent positive by bringing it up to the numerator of my fraction. And that's going to leave the fraction without a denominator, and that's okay for me. That might not be okay for you when we get to the next step. So it would have been okay on this step if I left this as a fraction with a 1 in the denominator. And that might be a better way to think of this when we go to handle the second negative exponent. So I need to make both negative exponents positive. Inside a fraction, a negative exponent can just be moved up and down from one side of the fraction to another, as long as there isn't any adding or subtracting inside the fraction. When you have a negative exponent that outside of parentheses that contains a fraction, to make that negative exponent positive, you take the reciprocal of the fraction and change the exponent from negative to positive. So that's why I think this okay version is probably better, because it helps you make this negative exponent positive. Because the negative exponent outside of parentheses that contains a fraction can be made positive by just taking the reciprocal of that fraction inside the parentheses. Now I just need to cube everything in the parentheses. So I'm going to get a 1 cubed, 2 cubed, x cubed, and y to the 5 times 3. I'm ready for my answer. 1 to any power is 1. 1 cubed means 1 times 1 times 1, and that's equal to 1. In the denominator, 2 cubed is 2 times 2 times 2, which is 8. X cubed is already reduced in the denominator, and y to the 5 times 3 gives me y to the 15. So 1 over 8x cubed, y to the 15th is perfect. 16 I could do on my calculator, so I'll try that. Parentheses, fraction 3 over 4, parentheses, exponent negative 2. So it looks enough like that problem that when I hit my enter, it should be to give me the right answer. The answer to this is 16 over 9. I would strongly prefer you showing some work. If you tried and didn't show any work and made any calculator error, you're not going to get any partial credit, and the work is easy to show. Here I have no negatives inside the parentheses, so I don't have to worry about moving anything inside the parentheses. I'm going to make the negative 2 into a positive 2 by flipping the fraction 3/4 and making it 4/3. So if you have a negative exponent that applies to a fraction, you flip the fraction, make the exponent positive. Now I just need to square the 4 and square the 3. 4 squared is 4 times 4, which is a 16 in my answer. 3 squared is 3 times 3, which is a 9 in my answer. So 16 over 9 is perfect for an answer. Still in section 2. In section number 17, the negative exponent is in the numerator. I need to take that x to the negative 3 and get it a positive exponent by moving it down to the denominator. When I do that, I'm going to leave nothing behind in the numerator of my fraction. I can't write a fraction without a numerator, so I'll leave a 1 behind in the numerator. It's okay to write a fraction without a denominator, but you can't write a fraction without a numerator. So if you take everything out of the numerator, you have to leave a 1 behind. And now the x's, they're being multiplied, so I'm going to add their exponents. And my answer is going to be 1 over x to the 5th. Not sure how many problems are on this review, but I think we're into section P3 now. Oh, there are 35 problems. And so about halfway, but maybe not really halfway. So 18 and 19 want me to just change the letters to numbers and simplify. So in 18, I'm going to go leave the negative sign there. I'm going to put the x in a parentheses and make it negative 2. I'm going to put the y inside a parentheses and make it 4 and square it. Bring my plus sign down, and then 2 times y is 4, z is 3, minus 2 times negative 2 cubed times 4. So I'm just replacing each letter with the numbers negative 2, 4, and 3. And I'm going to do orders of operations or my calculator. I think I can enter this on my calculator pretty quickly. So I'm going to go negative parentheses negative 2 parentheses 4 squared. So that's the first piece. And then plus 2 parentheses 4 parentheses 3. That's the second piece. And then minus 2 parentheses negative 2 exponent 3, get out of the exponent parentheses 4. There's the third piece, and when I hit enter, I get an answer that's got to be correct of 120. This is all I would show on the test, but if you want to do this by hand, we'll do it by hand. So by hand, I do exponents first. The first exponent, 4 squared, is 16. The second piece doesn't have an exponent. I'm going to leave it alone. The third piece, the exponent, is negative 2 cubed, which is negative 2 times negative 2 times negative 2. You get a negative 8 for this one, times 4. Now I'm going to get rid of this double negative here. This double negative is going to turn to a positive 2, and a positive 2 times 16 is going to be 32. Second multiplication, you go 2 times 4 is 8, and then 8 times 3 is 24, and we'll leave the plus sign. Third multiplication, negative 2 times negative 8 is positive 16, and then I do 16 times 4 is 64. Then I'm left with 32 plus 24 plus 64, and that equals to 120. So I more or less did it by hand, but then I got to the point there where I could add those in my head, but I probably would have messed up and I resorted to my calculator. I'll do the same thing for 19. I'm going to take the y in problem 19 here and change it to a 4, and then minus 2, and I'm going to change the z to a 3, plus 6, I'm going to change the x to a negative 2, the y to a 4, and then minus 1. Again, I could do this on my calculator, so I can try that. I'm going to go 2 parentheses 4 exponent cubed minus 2 parentheses 3 squared plus 6 parentheses negative 2 times 4 minus 1 equals, I believe the answer to this is 61. And again, I'll do it as much as I can by hand just to confirm my calculator's work. First thing I'm going to do is 4 cubed. Do the exponents first. 4 times 4 times 4 is 64. So I get 2 times 64 minus, and then I'm going to do the 3 squared, which is 3 times 3, which is 9. So minus 2 times 9 plus 6 times negative 2 times 4 minus 1. 2 times 64, 128. 2 times 9, I'm going to have a minus 18. 6 times negative 2 is negative 12 times 4 is negative 48. So I'm going to get a minus 48 and then a minus 1. By hand, 128 minus 18 is 110. Bring down the minus 48 and the minus 1. 110 minus 48, I think, is 62. And 62 minus 1 is 61. By hand, I probably would have got to there and then go 128 minus 18 minus 48 minus 1. And I'd still get that 61. So usually, even if I'm doing things by hand, when I get to the string of adding and subtracting, I don't do that as well in my head, and I resort to my calculator. In 20 and 21, I just need to combine like terms. First, I'm going to write the problems without the parentheses. And because there's a plus sign between the parentheses, I don't have to do any foiling, nor do I have to change any signs when I drop the parentheses. So problem 20 written without the parentheses can look just like that. It's just the same as the original problem, but it just doesn't have the parentheses. Now I'm going to write the cube terms first, the negative 6y cubed and the 5y cubed. Then I'm going to write the squared terms. The 3y squared now is going to need a sign, so I'll put a plus sign in front of it because it's not negative. And then the 4y squared. And then I'm going to write the y terms. Positive, I'm going to now write this as 1y as opposed to just y, and minus 3y. So I just dropped the parentheses, didn't have any changing to do. It's not a foiling problem because it's an addition, not a multiplication problem. I gathered together the cube terms, the square terms, and the first power terms. Now I'm going to combine. For the cubes, I go negative 6 plus 5, and that gives you negative 1, and then the letter is going to stay y cubed. 3y squared plus 4y squared is going to be 7y squared. And then 1y minus 3y, I need to do 1 minus 3, which is going to be negative 2, and then I get the y. This would probably be the answer I would write, but it probably would be better in terms of an answer if you didn't have that 1 in front of the y cubed. But in that box is a fine answer. But if you wrote negative y cubed plus 7y squared minus 2y, that's probably a more desirable answer. We do the same thing for 21. I'm going to drop the parentheses. Say this is 8z squared plus 5z cubed plus 4 plus 6z cubed plus 2z minus 7. Now I'm going to gather the cube terms, so that's a 5z cubed and a 6z cubed. Then I'm going to write the 1 square term, which is 8z squared. And then I'm going to write the 1z without the exponent, which is the first power term. And then I'm going to write the 2 numbers without the letters. So that's grouping the things in a nice order so you can see what needs to be combined. The answer is going to be combined. I'll combine the 5z cubed and the 6z cubed, and that's going to give me an 11z cubed. The 8z squared doesn't combine with the 2z because they don't have the same exponent, and you can only add when the letters have the same exponents. The 2z doesn't combine with anything because there's no other term with a z to the first power. And the 4 minus 7, I'm going to write a minus 3. You could have written 11z cubed plus 8z squared plus 2z plus a negative 3 if you really cared to, but that would be kind of unusual but not wrong. So if you happen to write that, you're doing well. It's just you're doing something that's kind of unconventional. Next two problems are probably subtraction problems and fractions. So I need to drop the parentheses. The first parentheses, because there's no sign or multiplication or exponent, I can just drop it. The second parentheses, I need the opposite of it. The opposite of positive 3/4 x is negative 3/4 x. The opposite of positive 4/3 is negative 4/3. Now I'm going to group the 1/2 x and the minus 3/4 x and the plus 2/3 minus 4/3. I'll do this on my calculator first. I'm going to go 1/2 minus 3/4. So 1/2 minus fraction 3/4, and I get negative 1/4. So in front of the x is supposed to be negative 1/4. So part of my answer would have negative 1/4 x, which you could actually write as negative x over 4. Would look strange, but it'd be okay. And then the next piece of my answer, I do 2/3 minus 4/3. That's easier for me, but I'll do it on my calculator again. 2/3 minus 4/3, and you get negative 2/3. So both of these would be correct answers, negative 1/4 x minus 2/3, or negative x over 4 minus 2/3. If you wanted to do this without a calculator, then these two terms, you need a common denominator. You'd multiply the x term by 2/2, then you'd get 2/4 x minus 3/4 x, and that's going to, you have to subtract the 2 minus 3 and leave the 4 and the x the same, and that gives you the negative 1/4 x. And these guys, it's just, that's going to be 2 minus 4 over 3, and that's the minus 2/3. So both of those are correct answers. You can definitely do the fraction work on your calculator. 23, first parentheses I can drop without changing anything. 4xy is a second degree term, so I should probably note that because I have to write the things in a nice order. I add the exponents of the x and the y, which are 1 and 1, to figure out that's a second degree term. The second term, it's a third degree term because I add the exponent of 2 on the x and 1 on the y, and you get third degree. And then the 3x, the only letter has an exponent of 1, so that's a first degree term. There's a minus sign in front of the second parentheses, so I have to write the opposite. The opposite of 5x is negative 5x. That's another first degree term. The opposite of negative 6xy is positive 6xy. That's another second degree term. The opposite of positive 7x squared y is negative 7x squared y, and that's a third degree term. So now I'm going to group the terms third degree, second degree, first degree. So the third degree terms are negative 2x squared y and negative 7x squared y. The second degree terms are plus 4xy and plus 6xy. And the first degree terms are plus 3x and minus 5x. And now I've actually written the terms how they can be combined. So these can be combined because they have the same letters with the same exponent. The numbers in front of each of these terms is negative, so I'm going to add the numbers 2 and 7 and keep them negative. And in my answer, I'm going to have a negative 9 with the x squared y. And then 4xy and 6xy gives me a 10xy. And then 3x minus 5x gives me negative 2x. So the best answer for 23 that I could come up with would have a negative 9x squared y, a plus 10xy, and a minus 2x. Ugh. 24 is an uglier multiply. I'm going to write it in a nice order without the parentheses. So I have to go 2/5 times 10/4 x times x, which I don't really need a times sign, and y to the 4th times y. The 2/5 times 10/4 I think is 1, but let me do that on my calculator. 2/5 times fraction 10/4, and I get 1. So I don't need to write that result. And by hand, doing that multiplication, I'll go 2 cancels with 4. 2 divided by 2 is 1. 4 divided by 2 is 2. And then 5 cancels with 10. 5 divided by 5 is 1. 10 divided by 5 is 2. These 2's that I canceled out can still be canceled with each other. 2 divided by 2 is 1. 2 divided by 2 is 1. What I have left in the numerator is 1 times 1, and what I have left in the denominator is 1 times 1. That's why when I did 2/5 times 10/4 on my calculator gave me a 1. I don't need to write a 1 as a coefficient, but it would be okay. So in my answer, if I want to write the result of the multiplication, I'm going to write a 1, but I don't have to. And for the x's and the y's, I'm going to add their exponents. The x's have exponents of 1s that aren't written, but they're assumed. The second y has an exponent of 1 that's not written but assumed. And when you add the exponents, you get that. So probably a better answer would be x squared y to the 5th, but you certainly can write the 1 in front. 25 is a really horrible FOIL problem, so I'm going to do firsts. Firsts are 5/3 y times 6/7 y. And when I do that, I have to go 5/3 times 6/7 and y times y. I'll get back to that in a second. The outers are 5/3 y times a -3. And when I do that, I have to go 5/3 times -3 times y. The inners are 2 times 6/7 y. That's actually written in the order that I need it to be in, 2 times 6/7 y. And the lasts are 2 times -3. And that's written in a decent order too. So those are the foiling. Now I wrote them in a nicer order. So 5/3 times 6/7, I'll do this. So 5/3 times fraction 6/7. The 5/3 times 6/7 is supposed to give me a 10/7. So in my, like one part of my answer is going to turn out to have the number 10/7 and a y squared. To get that 10/7 by hand, I'd cancel this 3 with this 6. 3 divided by 3 is 1. 6 divided by 3 is 2. I'd multiply the 5 and the 2 to get a 10. I'd multiply the 1 and the 7 to get a 7. And then the y's, I add their exponents. Second multiplication of fractions is 5/3 times -3. So fraction 5/3, then times parentheses -3. That comes out to be -5. So in the middle here, I'm going to get -5y. This is because this 3 will cancel with this -3. 3 divided by 3 is 1. -3 divided by 3 is -1. I don't need to write a fraction because it only has a 1 in the denominator. I multiply this 5 by that -1 and get a -5. Next multiplication is 2 times 6/7. So I'm going to go 2 times parentheses fraction 6/7, close out my parentheses, and I get 12/7 for the number that goes in front of the y. And then the lasts are -6. All I need to do is combine the outers and the inners, and to combine the outers and the inners, I have to combine a -5 plus a 12/7. Let me just figure that out quickly with this. So -5 plus fraction 12/7. I should get -23/7. So my answer for the y part is going to -23/7y. So I'm going to write the answer up here because I'm kind of running short on room down there. So in my answer, the first 10/7 y squared is going to be part of my answer. The middle term is going to be -23/7. And then when I combine those things that I boxed, the y stays the same, and the lasts are -6. If I wanted to do that, to get that -23/7 without a calculator, I'd make the -5 -5/1. Then I'd multiply this by 7 over 7. And this would give me negative 35 over 7 plus 12 over 7, which is negative 35 plus 12 over 7, which is negative 23 over 7, just like my calculator gave me. Honestly, I would do my fraction work on my calculator just because it's a lot safer. I make a lot less mistakes pressing buttons than I do trying to do some work by hand. And all the fraction work in this test, even if you do it by hand, double check on your calculator so you don't get points off for something that you just made a silly mistake on. 26 is just a distributive, and 27 is just a distributive problem too. 26, I'm going to multiply negative 3b times 2b squared. I'm going to multiply negative 3b times negative 5b, and I'm going to multiply negative 3b times negative 7. The first one, you need to go negative 3 times 2 and b times b squared. And that's going to give me negative 6. The first b has an exponent of 1, so I pick up a b cubed. The second one, I have to go negative 3 times negative 5 and b times b. Negative 3 times negative 5 is positive 15. The b's have exponents of 1, and when you add those exponents, you get a b squared. The last one, I go negative 3 times negative 7, and I leave the b, and I get plus 21b. That's the whole answer, because you can't add or subtract these because you don't have any of the same exponents, and you could only add or subtract when you have letters if the letters have exactly the same exponents. So that's all I could do for 26. 27, it's a little less pleasant. For 27, I'm going to go 3 halves y times 4y cubed. And to do that, I'm going to go 3 halves times 4 and y times y cubed. Let me just do that. Fraction 3 halves times 4 is going to be 6. So this is going to turn into 6. And then the y, so you get y to the 4th. To get that 6 by hand, this 2 will cancel with the 4. 2 divided by 2 is 1. 4 divided by 2 is 2. I only have a 1 in the denominator, so I don't need a fraction anymore. And then I'd multiply the 3 and the 2 to get my 6. Second multiplication is 3 halves y times minus 8y squared. So I'm going to go 3 halves times minus 8 and y times y squared. The 3 halves times minus 8, I'm going to break it out here. Fraction 3 over 2 times minus 8. That's going to be minus 12. So this is going to give me a minus 12. And then for the y's, I'm going to have a y to the 3rd power. By hand, this 2 and this negative 8 cancel. 2 divided by 2 is 1. I don't need a fraction because I only have a 1 in the denominator. Negative 8 divided by 2 is negative 4. When you multiply the 3 and the negative 4, you get negative 12. Third multiplication, 3 halves y times minus 6y. For that, I go 3 halves times minus 6 and y times y. You can do that without my calculator. 2 goes into minus 6. 2 divided by 2 is 1. Minus 6 divided by 2 is minus 3. I'm going to multiply that 3 and minus 3 and get a negative 9. And those two y's have exponents of 1. When you multiply those, you get y squared. Last multiplication is this 3 halves y times 12. And what I need to do is go 3 halves times 12 times y. You can do that on your calculator, or you can do it by hand. This 12 and 2 cancels. 2 divided by 2 is 1. I don't need a fraction. 12 divided by 2 is 6. I multiply the 3 and the 6 and get a positive 18. And I leave the y alone. So for an answer to this, 6y to the 4th minus 12y cubed minus 9y squared plus 18y. It says 18y. Hardly looks like it. It's the best I can do. Again, you could do all that fraction work that I did by hand on your calculator if you want to. 28 and 29 are both foiling problems. 28, I could be clever and only do the first and the last because they're conjugates, but I'll pretend I didn't know that. So I'm going to just do regular FOIL. Firsts are 2x times 2x, which is a 4x squared. Outers are 2x times minus 8, which is a minus 16x. Inners are 8 times 2x, which is a positive 16x. Lasts 8 times minus 8, which is a minus 64. Because these were conjugates, meaning they have the same two things inside the parentheses with opposite signs, the outers and the inners were going to cancel. So I really should have only done the firsts and the lasts, because anytime you multiply conjugates, or difference of squares, the outers and the inners cancel. My answer for this is just going to be what's left from the firsts and the lasts, which are 4x squared minus 64. 29 doesn't look like a foiling, but when I write 29 without its exponent, 3x plus 2 quantity squared is the same as 3x plus 2 times 3x plus 2, turns into a foiling problem. The firsts are 3x times 3x, which is a 9x squared. The outers are 3x times 2, which is a positive 6x. The inners are 2 times 3x, which is another positive 6x. And the lasts are 2 times 2, which is a positive 4. The outers and the inners don't cancel. They combine to be a 12x. My answer for problem 29 is going to be 9x squared plus 12x plus 4. So again, that's 9x squared plus 12x. Can't write right now. Plus 4. 30 is another difference of squares, or conjugate. I don't have to do outers and inners, but I can. It's a little bit messier, so if you just did the first and the last, you're saving yourself some work. But if you didn't catch that, you could do firsts. 5x times 3x is 15x squared. Outers, 5x times minus 2y. I multiply the 5 and the negative 2 and get a negative 10, and I leave the x and the y. Inners, 2y times 3x. I multiply the 2 and the 3 and I get a positive 6, and I write the x and the y alphabetically. Oh, they're not conjugates. I was being stupid. They're not conjugates, because this one does, if that was a 3, they would be conjugates, but they're not conjugates, so I had to do the foiling, because they're not exactly the same, because the 5 and the 3 aren't the same. So I looked at it, and luckily I'm doing all the work, because I would have got it wrong. Because in order for the outers and the inners to cancel, you have to have exactly the same contents, not the same, almost the same. So my last 2y times minus 2y is minus 4y squared. The only things that can be combined, and that's normal when you're foiling, are the outers and the inners. And when you do minus 10 plus 6, you get a minus 4, and I leave the xy. So I'm going to bring down the things that don't combine. So I'm going to bring down the 15x squared. These combine to be negative 10 plus 6 is negative 4, and I leave the xy alone, and then minus 4y squared. 31 is another foiling problem that doesn't look like a foiling problem, but when there's a minus inside a parentheses and you're asked to square it, you need to write it without the parentheses, and then you're going to foil. Firsts are x times x, which is x squared. Outers are x times minus 3y, which I'm going to write as minus 3xy. Inners are minus 3y times x. I'm also going to write that as minus 3xy. I like having the letters alphabetical. And then the last minus 3y times minus 3y. I multiply the minus 3's and get a positive 9. I multiply the y's and get a y squared. And then just like most foiling problems, the outers and the inners are going to combine. Those have the same sign, so you add the 3's and keep them negative, and you'll get a minus 6xy. So for my answer for problem 31, I'm going to get x squared minus 6xy plus 9y squared. Finally, to the last section, we have divide and check, and the checking is optional, but I'll do the checking. 32 and 33 I'm going to write as 3 separate division problems. So I'm dividing by a monomial. So I'm going to go 18s to the 4th t cubed over 6s t squared minus 12s cubed t squared over 6s t squared plus 2st over 6s t squared. This is a little bit different than the homework, but I can deal with it. This part's different, where you get a t in the denominator, but it shouldn't stump us too much. First fraction, 18 divided by 6 is 3. Subtract the exponents on the s's, 4 minus 1, and gives me an s cubed. Subtract the exponents on the t's, you get a t to the first. Bring down my minus sign. Second fraction, 12 over 6 is 2. Subtract the exponents on the s's, 3 minus 1 is 2, I get an s squared, and the t's cancel. Third fraction, 2 over 6 reduces. 2 divided by 2 is 1, 6 divided by 2 is 3. I get 1/3. The s's cancel, and for the t's, I subtract their exponent, and I have to leave the t where the larger exponent is, which is in the denominator. So my answer to this is going to be 3s cubed t minus 2s squared plus 1 over 3t. I doubt that in a test I'd make it so that you had a letter in the denominator. I think this is my answer. And remember how we checked? We checked by plugging in 2 for one letter and 3 for another. So for my checking, I'm going to let s equal 2 and t equal 3 and shove it in here. I'm going to go 18 times 2 to the 4th 3 cubed minus 12 times 2 cubed times 3 squared plus 2 times 2 times 3 over 6 times 2 times 3 squared. No way I would do that without my calculator, and I'm really going to be pushing it to do this right on my calculator. So fraction 18 parentheses 2 exponent 4 3 exponent 3, that's the first piece, and then out of the exponent minus 12 parentheses 2 cubed 3 squared, that's the second piece in the numerator, and then plus 2 parentheses 2 parentheses 3, third piece in the numerator, go down to the denominator, 6 parentheses 2 parentheses 3 squared, got the denominator in. This whole thing reduces to 577 over 9. Never would attempt that without a calculator. Now I need to go to my answer and plug the same stuff in. So I'm going to go 3 times 2 cubed times 3, plugging in 2 for the s and 3 for the t, minus 2 times 2 squared plus 1 over 3 times 3. So that just take this s, that t, that s, and that t, plugged in 2 and 3. And I better get 577 over 9. So first piece, 3 parentheses 2 cubed parentheses 3, first piece, minus 2 parentheses 2 squared, second piece, plus fraction 1 over 3 parentheses 3, third piece, enter, beautiful. And it's also 577 over 9. So I'm certain my answer is correct, or as certain as I can be. Next piece, it's still dividing by a monomial. I'm going to write it as 3 separate fractions. I'm going to write it as 12x to the 4th over 2x minus 16x cubed over 2x plus 6x over 2x. First fraction, 12 over 2 reduces to 6. I subtract the exponents on the x and get an x cubed. Bring down my minus sign. Second fraction, 16 over 2 is 8. Subtract the exponents on the x's and get an x squared. Third fraction, reduce the 6 over 2 and get a 3 and keep the x alone. This should be the answer. And I'm just going to plug in x equal to 2 for my check. So to plug in 2 for there, I'm going to go 12 times 2 to the 4th minus 16 times 2 cubed plus 6 times 2, close out that parentheses, then divided by 2 times 2. I'm going to enter it just like that with every parentheses that I have there. If I don't hit every parentheses, I'll probably get an error message. So first bit, can't see this, the best I can do here. So parentheses, 12 parentheses, 2 to the 4th minus 16 parentheses, 2 cubed plus 6 parentheses 2, another parentheses, divided by parentheses 2, parentheses 2, double parentheses, equals 19. Now I'll do the same thing with the answer. I'm going to go 6 times 2 cubed minus 8 times 2 squared plus 3 times 2, and hope I get 19 again. So double check that the best I can. 6 parentheses 2 cubed minus 8 parentheses, get out of the exponent, minus 8 parentheses 2 squared plus 3 times 2. So the best I can, I enter that line, better get 19, I get 22. That's not a good thing. Either I have a mistake or I entered something wrong. So let me double check my work. 12 over 2 is 6, x cubed seems reasonable. 16 over 2 is 8, x squared seems reasonable. And I see my mistake right here. The 6x was supposed to be divided by 2x, and I should have just gotten a 3. Which means both of my checkings were wrong. Let me redo my checkings on another sheet of paper because I have a wrong answer. That's the beautiful thing about checking, is it helps you on your answers. So checking the original problem, it's going to be the same. The original problem, I'm still going to get 19 because I didn't mess up on the original problem. Maybe I can just check my answer here. So I should have done 6 times 2 cubed minus 8 times 2 squared plus 3. There shouldn't be an x in my answer because the x should have canceled. I forgot to write it. That's why we check, because it helps us catch mistakes. So now I'm going to try this. 6 parentheses 2 cubed, get out of the exponent, minus 8 parentheses 2 squared plus 3, and it gives me the 19. So that's the why I say this check, but why I don't often check is because it takes so long. So it's, I don't know. If you have the time and check, you're going to save yourself the grief of losing a point or two for making a dumb mistake like I just made here. So the answer is 6x cubed minus 8x squared plus 3. And I checked it and I caught that mistake. 34 and 35, long division. Write it as a long division problem. So as a long division problem, this is going to be 2x plus 5 divided into 6x squared plus 7x minus 20. For the first top, I go 6x squared over 2x. 6 divided by 2 is 3. X squared over x is x. I get a positive 3x on top. Then I multiply to figure out what's under. So I'm going to go 3x times 2x plus 5. That's going to be 3x times 2x is 6x squared. 3x times 5 is plus 15x. I'm supposed to subtract this, so I'll put it in a parentheses to indicate what I would do if I was going to subtract it. But instead of subtracting, I'm going to find the opposite of this and put the opposite under, which is going to be minus 6x squared minus 15x. So minus 6x squared minus 15x. 6x squareds cancel. 7x minus 15x is minus 8x. I bring down the minus 20. For the next step, the top is negative 8x over 2x. The x's cancel and you get a negative 4, which I'm going to write on top. The underneath, you go negative 4 times 2x plus 5, which is negative 8x minus 20. I need to subtract that, so I'm going to find the what it looks like when I subtract it by putting a negative in front of a parentheses. Find the opposite to drop that parentheses. The opposite of negative 8x is positive 8x. The opposite of negative 20 is positive 20. So I put in 8x plus 20, and I get a remainder of 0. So my answer is supposed to have a remainder of 0, so I'm supposed to check, so let me do that checking. The answer is 3x minus 4 with no remainder. Let me go ahead and plug 2 into the original problem for my checking. So I'm going to go 6 times 2 squared plus 7 times 2 minus 20 divided by 2 times 2 plus 5. I'll do that, and then I'll come down here and go 3 times 2 minus 4. Better get the same results. This one I could do in my head. This is 6 minus 4, which is 2. So when I do this, I better get 2, because that's what I get when I plug in 3 times 2 is just 6 minus 4 is 2. So now I try this out. Go parentheses 6 parentheses 2 squared plus 7 parentheses 2 minus 20 parentheses, have that part in. Now divided by parentheses 2 parentheses 2 plus 5, close out my parentheses, and I get 2 again. So because when I plug a number into the original problem and I plug that same number into my answer, because I get the same number, my answer must be correct. And I only do that when the remainder is 0, otherwise it's a little tricky to do the checking. Last one, write it as a division. So it's going to be x minus 3 divided into 3x squared minus 8x minus 3. The first top, I go 3x squared over x, which is going to be 3x. So I'm going to write a 3x up here. And then for the under, I'm going to go 3x times x minus 3, which is 3x squared minus 9x. I'd like to subtract that, so to subtract it, I put it in a parentheses with a negative in front. I'll drop the parentheses by finding the opposite. The opposite of positive 3x squared is negative 3x squared. The opposite of negative 9x is positive 9x. This is what I'm going to put down here. So negative 3x squared plus 9x. The 3x squareds cancel. Negative 8x plus 9x is positive 1x. Bring down my negative 3. Next on top, I'm going to go this 1x over that x. The x's cancel, you're left with a positive 1. So I put a positive 1 on top. For the under, I take this 1 and multiply it by that x minus 3. Anything times 1 is itself. I need to subtract it, so I'll subtract it by putting a parentheses with a minus in front. I'll drop the parentheses by finding the opposite. The opposite of positive x is negative x. The opposite of negative 3 is positive 3. So under here I'm going to put a negative x and a plus 3. The x's cancel, the 3's cancel, I get a remainder of 0. And my answer has a remainder of 0, so I should check. My answer is 3x plus 1. And I'm going to check by plugging 2 into the original problem and 2 into my answer for the x. I like using 2 just because it's smallish, it's not too hard to use. So I'm going to go 3 times 2 squared minus 8 times 2 minus 3 over 2 minus 3. And I'm also going to go 3 times 2 plus 1. That's 7, because 3 times 2 is 6 plus 1 is 7. That better equal 7 for this to check properly. So now I'm going to check this and be done. So fraction 3 parentheses 2 squared minus 8 parentheses 2 minus 3 over 2 minus 3, and I get 7 again. So because when I plug 2 into the original problem, I get 7, and when I plug 2 into my answer, I get 7, I feel like my answer is correct. So that's everything on the review. This review had 35 problems. I would be very surprised if the test had more than 25 problems. So figure maybe 20 problems at 5 points each, or 25 problems at 4 points each, but never 35 problems. My reviews are always longer than my tests, and I never try to make my tests harder than the review. I actually strive to make my tests a little bit easier than the review. You can do every problem on this review out of order, so maybe problem 35 might be problem 7, and problem 16 might be problem 20. you should be completely fine on the test. If there's anything on the review that you just can't completely do, then you need to contact me and let me help you understand it before you take the test. And again, turn your homework in by the deadline, and you will be able to use a 3" by 5" note card when you take the test, and that's a huge advantage. So really take advantage of being able to use that note card.